Hi everyone. The topic for today's presentation is face mask detection. The group members are Akshada, Ishan, Jagadeesh, and Navin. The motivation behind this project has been the COVID-19 pandemic, which is still raging in some countries. In order to study the spread of virus, determining if people are wearing masks properly or not is very important, and our project is based on this line of thought. The Python code which we have developed will classify each face in a particular image or video into one of the three categories, that is with mask, without mask, and improperly worn mask. The first step of the project was to load the training data set. Then we trained our mask classifier models on the training data set, and then we tested this model on the test data set. For this project, we have used 5 different models. The last one is for video. We have generated plots of loss and accuracy for each model, and then we have compared the models based on the running time and accuracy. For training, we have considered the face mask detection dataset from Kaggle, which consists of 853 images. And for testing, we have used the masked FaceNet dataset, which consists of around 2000 images classified in different categories. MobileNet V2 has been the first model which we have used. This is our base model. This is a convolutional neural network with 53 layers. We haven't considered the top layer for our analysis. We have built the model and then we have compiled it using the Adam optimizer. And then we have fitted the model on the training data using 20 epochs. This is the plot which shows the training loss and accuracy, and the epoch number has been shown on the x-axis. You will notice that as the epoch number increases, the loss drops and the accuracy keeps on rising. And the final numbers which we are getting are pretty satisfactory for MobileNet V2 model.
So in addition to the base model, the first model we have tried is based out of residual network or ResNet architecture. The advantage of ResNet is that extremely deep neural network with up to 150 layers can be trained successfully. For our purpose, we have used ResNet 50 V2 model. Same dataset as used for base model has been used for ResNet. To modify the input data, we have used average pooling 2D, flatten, and dense methods from TensorFlow Keras layers library. We have also used the pre-process input module from the ResNet V2 for pre-processing. Epoch is kept as 20, optimizer used is Adam, and the activation methods used are ReLU for hidden layers and softmax for top layer. The loss function used is categorical cross entropy, and the matrices used is accuracy. This is the plot for training loss and accuracy, where with the higher epoch numbers, the accuracy has increased for both training and validation steps. We have achieved highest validation accuracy with this model. The next model we have tried is Inception V3, which is widely used image recognition model for higher accuracy on ImageNet dataset. To modify the input, we have used global average pooling 2D and dense methods from TensorFlow Keras layers library. We have also used the pre-process input module from the Inception V3 for pre-processing. Other hyperparameters are same as what used for ResNet. This is the training loss and accuracy plot. With Inception V3, we have received highest training accuracy and the second best validation accuracy. The fourth model used for face detection on image is GoogleNet, which is a variant of Inception network. It is a 22-layer deep convolutional neural network developed by researchers at Google. It consists of 9 Inception modules. Similar to Inception V3, we have used global average pooling 2D and dense methods from TensorFlow Keras layers library to modify the input data. We have kept epoch as 25 and activation methods as ReLU and softmax. This is the training loss and accuracy plot with GoogleNet. Next few slides are the sample outputs for each model. In this particular case, all the models are correctly tagging the image. In this case, all the models are correctly tagging the faces, but 2 of the models are finding additional face, which is in fact not there. In this case, 2 of the models are correctly tagging the faces as incorrectly worn mask, but one of the model is saying correctly worn and the other is saying no mask. So both are incorrect. In this case, none of the model could identify all the faces shown in the image and are only providing partial outputs.
Along with testing the model on static images, we have also explored on how a real-time face mask detection system works. We have used an input dataset with around 1400 images, divided into two categories of people wearing the mask and not wearing the mask. For the model, we have used sequential model of Keras package as the base model. Image data generator library of Keras pre-processing image is used for image data augmentation. For testing purpose, we are using a webcam to get the real-time video feed. For every 10 milliseconds, the camera is capturing the image from the feed, and the faces are extracted out of image using cascade classifier method of OpenCV. Faces are then run through the saved model to identify mask on it. A rectangle with appropriate label color red or green is then drawn around the face. For the results, we can see here the model prediction. On the left side, we have predicted image with no mask, and on the right side, we have the one with the mask.
Here is the comprehensive table where we compare all the models and the parameters used in all the models. So if you see, we have fixed epoch as 20 for all the models, and then we have the training time for all the models. So the best model is mobile VNet 2 in terms of the training time. It's almost 10 minutes less than all the other models. But it doesn't necessarily mean it performed best. So the optimizers which you used in all the models are Adam, and the activation functions which were used in all the models are ReLU and Softmax. So for these models, we have captured loss accuracy metrics on the training dataset and the validation dataset. If you see on the training dataset, the Inception v3 model was performing a lot better in terms of accuracy, but on the validation dataset, it's not the case. On the validation dataset, the ResNet 50 model was performing a lot better than the Inception model. So in terms of both loss and accuracy on the validation dataset, ResNet 50 v2 turns out to be the best model than the other model. This is the slide which talks about what enhancements can be made on this model. Mainly, we want to have data augmentation done, which means we need to have more diverse set of images to reduce bias in the model. If you have more diverse population in the training set, and then we can reduce that bias or the error rate in the validation data sets. Then we can also do some hyperparameter tuning, like we can have learning rates adjusted, we can have epochs adjusted, we can do a batch size adjustments, and we can use momentum in the hyperparameter tuning, and then those things can be done, and then we can figure out the best output for it. Then we can test another architectures like AlexNet and VGGNet apart from the things which we already used, and then figure out the best model which can be done, which can be used. The other important feature which we want to add is we want to classify classify the faces as improperly worn mask. Also, right now we only classify as with mask and without mask, but adding improperly worn mask is also important, so that we know if the mask is there but they didn't wear it properly. Conclusion, this project is pretty much relevant to what's happening in the world right now, and then we hope somebody will be using this project to enforce these mask rules.